Hello friends, welcome back. In this tutorial we will study about pushdown automata. First of all, see that this language a raised to power n, b raised to power n, where n is greater than or equal to 0 is not a regular language. It is not recognized by any finite automata. Now see why this language is not recognized by finite automata. See, this language contains strings in which number of A's is equal to the number of B's and no B is followed by an A, right? So why finite automata cannot recognize this language? Since in the strings of this language number of A's are equal to the number of B's, right? So finite automata needs a memory to remember how many A's it has read, right? Since finite automata doesn't have any memory, so it doesn't remember how many A's it has read, so it cannot recognize this language, right? But if we add some memory to a finite automata, then it will be able to memorize something, and definitely its power will also be increased. Then it will be able to recognize such type of languages. So when we add a stack to a finite automata, then we get a new machine that is called pushdown automata, right? See, pushdown automata is non-deterministic in nature. It is like NFA. It may have choices of moves in each situation. It consists of an input tape, a finite control, and a stack. A string of input symbol which this pushdown automata is going to read is written on input tape, right? Now this hat points to the input symbol on input tape to which this pushdown automata is going to read. This hat points to the top element of the stack. Now there are two types of moves in pushdown automata. In first type of move, it reads an input symbol from input tape, right, and reads the top element of the stack, and after reading input symbol and top element of the stack, it changes its state, manipulates the stack, and move this hat towards one position right. Now it will point to the next input symbol of the input tape, and this hat will point to the top element of the stack, right? It is a first type of move. Second type of move is called empty moves. In that type of moves, pushdown automata doesn't read input symbol from input tape. It just reads the top element of the stack, right, and manipulates the stack, changes its state, and this hat will point to the top of stack, and this hat doesn't move to the right because it has not read any input symbol from input tape, right? So such type of moves in which pushdown automata doesn't read input symbols from input tape, right, such types of moves are called empty moves. In each move of push-down automata, following operations can be performed on a stack. First, top element can be removed from stack. This is called pop operation. A string of stack symbols is pushed in a stack. Third, a top element is replaced by a string of stack symbols. Right. So these types of operations can be performed on a stack in moves of push-down automata. A push-down automata M is defined by 7 tuple Q, sigma, T, delta, Q naught, Z naught, F, where Q is a finite set of states, sigma is a set of input symbols, T is a set of stack symbols. These are the symbols which can be put in a stack. Q naught is the initial state of push-down automata. Z naught is a particular stack symbol called stack starts symbol. When a push-down automata starts, its stack contains only one symbol, that is, its stack start symbol, right? F is the set of final states of push-down automata. Delta is a mapping which describes the moves of push-down automata. Now see, it takes this delta takes 3 inputs. One is the present state, current input symbol, and the string in the stack, right? Or it may just take the top element of the stack, because only the top element of the stack is going to affect the move of push-down automata, right? So when the string is given, then its leftmost symbol is the top of the stack. So suppose machine is in state Q, it reads an input symbol A and top of the stack is Z, right? Now for this it has 3 options. It can either move to state Q1 and push an element A to stack, right? It has two other options also. It can move to state Q2 and remove the element Z from the top of a stack. And another option is it can move to state Q3 and replace this top of a stack Z by the stack element X, right? So in this way, this delta describes the moves of push-down automata. Now see, output of this function delta is a set having 3 elements. It means for this particular situation, when the machine is in Q state and it reads input symbol A and Z is at the top of the stack, it has 3 choices, right? It can either move in state Q1 or in Q2 or in Q3. When it is in Q1, it pushes an element A to stack. When it moves to state Q2, it pops the element Z. When it moves to state Q3, it will remove the element Z by X, right? So when the push-down automata is in state Q, reads an input symbol A and top of its stack is Z, it has 3 options, right? Now see this move, delta Q empty Z. Now it is equal to a set having two elements. One is Q1 AZ, another is Q2 empty. Now see what it shows. It shows that when machine is in state Q and it doesn't read any input symbol, right? And top of the stack is Z, then it can either jumps to state Q1 and will push an element A to stack, or it can jump to state Q2 and remove, or we can say pop, the element Z from the stack. Now see, here in this move, which is described here, in this move, Pushdown Automata is not going to read any input symbol. So this is an empty move, right? So when machine is in state Q and it doesn't read any input symbol and top of a stack is Z, then it has two options, right? So in this way, this delta function describes the moves of Pushdown Automata, right? Thank you very much.